Hello, everyone. Thank you for joining our breakout session as part of the WISP Virtual Summit 2020. Please stay with us till the end, and you will get a code to get 20 points. My name is Gerrit Nagelhout. I'm the CEO of Preseem, and I have with me Tyler Casey from DM Tech.
Hey, guys.
All right, let's get started here. So in this session, I'm going to start off with a bit of a background about quality of experience and Preseem, how to measure it, how to use it to improve your network and shaping optimization. I'll talk a little bit as well about COVID-19 and sort of the special challenges. And then I'm going to hand it over to Tyler to talk about his experience with Preseem from onboarding to improving his network and that kind of thing. Let's start with a bit of a definition. What is quality of experience? Quality of experience is all about how your customers perceive your service. The main factors impacting it are bandwidth, are people getting their planned speed, latency and jitter without having to wait for packets, and packet loss. Now, bandwidth typically gets the most attention, but latency is often much more important. If you think about applications like gaming, VoIP, browsing, they don't use a lot of bandwidth, but it's really important that the latency is low. And what happens is if your latency is high in your network, those applications start feeling really slow. And your customers will feel that. They will think there's a bandwidth issue, run a speed test, maybe it shows a bit too low, and then they will call you with complaints. If you can keep that latency low, chances are you're not going to get those calls in the first place. You'll have much happier customers. And if you think about poor QoE, it basically results in slow feeling internet. Whenever bits are flowing, but it feels slow, that's usually a quality of experience issue. Now, Preseem is deployed in hundreds and hundreds of fixed wireless networks, so we've learned quite a lot about what some of the common causes are for QoE issues. And we found that the number one issue is your shapers and how you do plan enforcement. How you enforce your customer's plan speed. Say you have a 5 meg or 10 meg plan, how you do that has a really big impact on the user experience, especially when they max their plan out. I'll talk more about that in a few slides. The next big one is honestly your access points, your last mile connectivity. We see the most variability there from sort of any gear in the network. And so if you think about like a 1 gig fiber connection, chances are you're going to get about close to 1 gig of throughput. With an access point, even under perfect conditions, you're probably not going to get that close to what the specs say. And then you have to worry about things like interference and line of sight issues, which can cause it to be further underperforming. And so understanding what's actually happening at the AP level is really important. Then, of course, you have in-home Wi-Fi, maybe not something you can directly control, but understanding it is also important. Backhauls we see a little bit less often, but when you do have an issue, can impact a big chunk of your network, of course. And that's sort of less common again, but higher impact yet is transit capacity, of course. And an honorable mention goes to overloaded microtics as well. That can cause some particularly interesting issues for the user experience also. So the question is, how do you figure this out? How do you know where your problem areas are? And if you look at traditional network monitoring, it's really focused on the network elements. Are they up? Are they down? Can you ping them? Maybe you're graphing a bunch of counters over time. All useful stuff. Definitely keep doing that. But just because something is up and says it's fine doesn't actually mean it's delivering a good experience. And so really the question is, how do you figure that out? And one way to think about this is simply as the bottlenecks in your network. Whenever you have some kind of bottleneck, like a congested access point or an in-home Wi-Fi issue, you've got a piece of gear that has more data coming in than it can transmit. And what's going to happen is it's going to start buffering those packets and eventually dropping them. And from a user perspective, this really hurts because now they have less bandwidth at a higher latency and higher packet loss. And that's ultimately what causes things to feel slow. So the key then is to find all these bottlenecks. Now, the nice thing is that your existing TCP traffic on your network actually has built-in mechanisms to detect this. And with an inline device like Preseem, you can actually measure this. And the two big ones here are TCP round trip time and TCP retransmits. So TCP it's a connection-based protocol. Whenever a packet is dropped, it detects it and sends a new one. It sends a retransmit. So you can count those retransmits. And if the latency goes up, you can measure that through something called TCP round trip time. And this is a really important measurement that we can find a lot of problems with. So TCP round trip time is simply how long it takes for a packet to go from the inline device through your backhauls, your access points, CPE, right through home Wi-Fi to the end user device like a phone or laptop, iPad, whatever. And then TCP on that device sends back an acknowledgement packet saying, yep, I got that. The outcome's traveling back. And when that gets back to Preseem, it correlates those two. And it says up to 100 milliseconds, 200, whatever. That's one latency sample. And it just keeps doing that. And so now that you have that data, you can see exactly if any of your customers are getting a good experience or a not so good experience. Now, one thing to note here, these measurements are quite different from ICMP or ping. Those tools are useful as well, especially for connectivity checking and things like that. But ping, for example, some of the key differences, for one, it can't ping into the home. You at the demarc it stops. You can ping maybe your CPE, but you can't really go beyond that. Whereas round trip time goes right past. And the other big one is that because ping is an injected packet versus the actual customer's traffic, the network elements tend to handle it sort of in a special case. Sometimes the priority is higher, sometimes it's lower, but the actual latency of the ping is often not what the user is experiencing. And so they're both useful, but they solve different problems. Okay, so talking about Preseem itself a little bit. Preseem is an inline device. You can have one server, you can have multiple. It's a layer 2 transparent bridge. We have appliances. You can provide your own hardware. And basically, each device measures all those the TCP measurements that I mentioned. So the round trip time, the retransmits, bandwidth, a whole bunch more stuff like that. And each appliance then logs all those metrics to our cloud service. We can log it into our dashboards and see what's actually going on. And then the cloud service then connects to your billing system as well. We support most of the popular ones in the WISP space. And the key information we get from there is your list of subscribers, what IP addresses they have, what plan speeds they have. And that then lets us do the shaping, which we'll talk about a little bit later as well. And the actual shapers themselves run on the inline device. So it takes over from, if you had a MikroTik router or a radio or something like that, you typically turn those off or change them a little bit, and Preseem would take that over. The other part we get from the billing system, typically, although there's other ways to get it as well, is a list of your access points. And the reason that's so important is we then connect to each one through SNMP. Typically, SNMP, there's some other ways as well, depending on what gear you have. But that lets us map out what subscribers are on what access point or eNode B in LTE lingo. And once you have that, let's say you have a subscriber with high latency, you can then compare their latency to everybody else in the same AP. If that subscriber is high and the rest is low, you've got a subscriber issue. If they all have the same high latency pattern, then it's a problem with the whole access point or possibly the backhaul. So this really lets you pinpoint where the actual issues are. And so then we've got a bunch of dashboards that let you figure this out, right? And we have those baseline metrics and then a set of derived metrics on top of that to help summarize this data into actionable insight to quickly figure out the access points that are overloaded or underperforming. This screenshot, for example, shows all the access points. It's a daily summary. For every day, we mark them as green, yellow, or red. Green means probably you can market those areas more. Red means it needs some attention. And then you can further drill down and figure out if you likely have too many subs on it, or maybe they're underperforming with something like interference. And some of the things to help you figure that out are we calculate, for example, the oversubscription ratio. So add all the plan speeds for all the subscribers on that sector and divide it by the typical throughput we expect to see for that model AP at that channel width. I'll talk a bit more about that on the next slide here. Because we've been so focused on a fixed wireless space, we're now monitoring tens of thousands of access points. And because of that, we have a really good sense of what a given model access point at a given channel width should be able to achieve based on real world examples. And so what we do is we come up with a number for every AP model, every channel width, and that's now actually embedded in our app as well. And so you can see it, it's one of our screenshots, that orange dotted line tells you exactly what to expect. So if you see a latency for the sector, which is on the top end of the chart in this case, that is higher, which is on the high side, then you know there's an issue. If your throughput is well below the orange line, think underperforming access point. If the throughput is well above the orange line or around there, think overloaded access point because it is pushing as much data as others like it. The other thing you can use all this data for is actually for customer support as well. And really the goal here is to put yourself in your customer's shoes. When they call you up and say, my internet is slow, whatever's happening, you can immediately tell if their latency is high. And if their latency is high, is it just them? Is it the whole access point? So now you can figure out, is it a subscriber issue? Is it a access point level issue? Or maybe they're both low and the bandwidth is too high and you need an upsell instead. And this gives you all the tools required to really do that very effectively and very quickly. The other half of Preseem, which we'll talk about next, is the shaping and optimization side. And I'll first talk a little bit about why is this important. So if you think about your typical bandwidth shapers, your MikroTik simple queues, the ones built into the radios, the Cambiums, Ubiquities, whatever the case might be, they do a good job making sure your customers don't exceed their planned speed. But when they max it out, the experience can become quite poor. And the reason for that is the simple shapers have one queue which all your customers' traffic goes through. So let's say that somebody in the house is watching Netflix and is maxing that connection out, that queue starts filling up and adding latency to Netflix. But because it's a shared queue, it's added not just to Netflix, it's added to everything. So now all of a sudden the latency for all the applications shoots up. And if you were doing some gaming or browsing, you start really feeling that. And it's this effect which can cause those calls of my internet is slow when somebody has maxed their connections out. And you might tell them, well, you're maxing your plan speed out, don't do that. But there's actually a fairly simple way to solve that problem. And so what Preseem does, we actually use a standards-based protocol called FQCoddle. You can Google more if you like, but in a nutshell, there's two big things it does to improve upon the simple queues. The first one is that it looks at every application or flow individually and classifies it as either bulk or interactive based entirely on how much data is going through there. So with something big like a Netflix or a download, it's classified as bulk. If it's something small like gaming, VoIP, or browsing, it's classified as interactive. And then what happens is the small stuff, the interactive flows, get prioritized. So it doesn't matter how busy your link is, you can always game, you can browse, you can do VoIP calls like nothing else is happening. And the remaining bandwidth is allocated fairly between all the bulk flows. Now, on the bulk flows, what happens is each flow will get its own queue. And the nice thing that happens there as well, that already separates them out a little bit, but then active queue management is applied. And what that does, it makes sure that even when the shaper kicks in, the latency remains really nice and low. And this is really important for things like video conferencing, for example, where there's both a fair bit of data and the latency needs to be low. And so it has a really dramatic impact, even on the big stuff. And so from a user perspective, it's just going to feel a lot faster when they've maxed their plan speed out. From your perspective, just update your plan speed in your billing system and Preseem takes care of the rest. There's not really any configuration required. You just turn it on and it starts doing its thing here. Okay, and last, you'll talk a little bit about COVID-19. So the big things that we've seen with people working from home and studying from home is more bandwidth, a bit more during the peak, maybe 20, 30%. But the biggest impact, I think, is that during the whole day or much bigger chunks of the day, the network is much busier. And I see Tyler shaking yes there. That's exactly what's happening, right? And you also see the mix of traffic is a little bit different. There's more video conferencing and sort of interactive applications. And again, the nice thing with FQCoddle is you don't really worry about it. You don't define what protocols to shape. There's no manual rules. It just automatically prioritizes all that, keeps the latency nice and low, and it just works. And it's really, the kind of classic example here, you've got kids watching Netflix in the basement, they won't mess up your important Zoom call. The other thing that we're seeing is if you already had access points that perhaps were a bit overloaded, that are now, so for a much bigger chunk of the day, the monitoring will tell you where this is happening. And then you can also apply shapers at the sector level to see, where that's happening, and then you can improve it by turning those shapers on. And the goal behind the shapers is you want to make sure the access point doesn't get overloaded, that it's Preseem FQCoddle that's limiting the amount of traffic, and it does so in a much lower latency way, a much better experience for the end user. Okay, so this is it for my part of the session, and I'll hand it over to Tyler here.
All right, my name is Tyler Casey. I am the network engineer and owner of DM Tech. We're a WISP headquartered in Corning, California. And a little bit about us. We were founded in 1994 as a PC retail and repair shop We later offered dial-up internet service, transitioned to WISP in the mid-2000s. My team and I purchased the assets from the founders in 2019. We're 100% employee owned, and we have almost 2,000 subscribers. So on the agenda for today, we're going to start off with why did we choose Preseem in the first place? And then we're going to talk about the onboarding, what it was like to get started, and then how we put Preseem to work to help us identify problems both at the network level and subscriber level, and then also how we used it to optimize some of our remediation processes. Then we're going to talk about what kind of effect it had on our whole business operations, and finally talk about the end goal, which is that performance and subscriber experience. So why do we choose Preseem in the first place? Well, pretty much at first, we didn't really need Preseem, or at least we didn't think that we would need Preseem for the visualizations and the metrics. We just needed a shaper that could handle our traffic. At the time, we were using a PowerCode GX426 BMU that was completely saturated. Maybe that's an understatement. It was experiencing nightly OSPF drops, random reboots, DHCP failures. 2.5 gigabits per second was the maximum that we could get across that thing. Combine that with the fact that it was end of life from PowerCode with no support or updates. It just wasn't viable for us anymore. We were also frustrated and exhausted with subscriber complaints that we were unable to investigate, and we were unable to proactively identify problems and remediate. So the onboarding was very simple integration for our topology anyway. The Preseem onboarding team was helpful and knowledgeable, and they actually worked directly with our CRM provider, PowerCode, which was great. As far as the appliance itself, the appliance installation was basically plug and play. It's a layer 2 device, so there's no routing required. And because it's layer 2, you can pretty much stick it anywhere, although Preseem does have a recommended topology location, which I'll show you. Here you can see our Preseem appliance in green. And because this is layer 2, you can actually form an OSPF adjacency through the appliance, which made it so seamless to integrate. The only requirement is that all traffic desired to be shaped must flow through the appliance. And here I actually created a high-cost alternate OSPF path to route around the appliance just in the event of technical issues or maintenance. Now let's talk about how we put Preseem to work. So let me ask you guys some questions. How are you identifying overloaded or problematic APs or backhauls? Are you using ping, airtime, throughput, CPU or mem usage? The problem with most of these methods is that they're not monitoring, they're only monitoring the device itself as opposed to the subscriber traffic flowing through it. But even monitoring the same metrics on the CPE or router level doesn't really provide an accurate representation of what the subscriber is experiencing. For example, you can monitor the ping of an AP, but that will really only tell you the round trip time to that device itself and back. Not very helpful for assessing the stations that are connected to it. A severely overloaded AP will show no symptoms via ping, and often CPU and mem will be well within expectation. So what if it's something that doesn't manifest in monitoring data at all, like weird TDMA behavior? How would you even know? Well, Preseem to the rescue. Why Preseem is different is because Preseem does not monitor the devices, but rather the traffic moving through the devices, called flows. It measures the latency, the TCP retransmit, and other metrics for the entire flow from end to end, including that Xbox that belongs to the gamer who's living in the trailer on grandma's property 50 yards away. You still can't monitor that Xbox, but you can identify that there is validity to the subscriber's complaint of lag that is resulting in him getting killed in Call of Duty by 12-year-old Korean kids. That's another argument for managed routers, by the way. So while it's still not your responsibility, you can at least get perspective about the subscriber's experience. And in our case, ultimately, this was revealing things to us that were previously impossible for us to see. And we were actually seeing substantiation of subscriber complaints that we would previously just have dismissed. So check out this access point. So you'll notice right at about 9:41, you'll see the TX and RX stats get noticeably worse. You should be able to see right in the middle here. And then this is the same AP zoomed out over several hours for more context. And you can see it looks like it stays much worse. And it actually shows that it really never improved after that change. Now, here is that same access point in Preseem. So previously, every subscriber showed a sharp decline after the change, yet Preseem shows latency and throughput were the best that they've ever been. Care to guess what the change was that caused this strange behavior? So get this. No channel change, no client improvement. We only changed the frame duration from Flex Legacy to Flex. So how is it that Air Control showed significantly worse numbers, but Preseem showed a clear, sustained improvement? Why this is so amazing to us, though, is that if we were only looking at Air Control, we would have certainly turned Flex back off because it would have appeared to be much worse. However, Preseem shows the unbiased story of the actual flows, and we can see it's an inarguable improvement. Air Control quite literally sabotaged us. And then here is an insane example of Flex mode being activated on a UBNT Prism. Again, no client improvement. Just look at the before and after latency and throughput on that access point. It's really dramatic. You know, we're talking nearly a 5-fold improvement in latency. It was massive. So let's talk about putting it to work at the subscriber level. How are you guys identifying subscriber level issues? Are you using ping, RSSI, CCQ, error rate, throughput? How do you troubleshoot those seemingly invisible complaints from subscribers? You see, most tools monitor and measure and record data and metrics about those devices. So when you combine the proper tools, you can monitor just about everything, which is great. However, sometimes, many times, all of your data looks good and there are no evident issues, but yet subscribers are still complaining. Why? It's because you're monitoring the devices required to get the service to the subscribers, not what the service feels like to the subscribers. What if they're having a device issue or a router issue? So here's a random subscriber. Note the sharp decline at TX and RX at about 9:41. Should be able to see that pretty plainly there. You can see something definitely changed. Well, here's where it gets weird. Here's the same subscriber in Preseem. Notice their latency improved enormously and stayed improved even during peak. This was a subscriber selected at random from the AP shown previously, where the only change was in the TDMA framing mode. Just check out the difference before the yellow line versus after the yellow line. Dramatic difference in latency. Here is a crazy example of CPE interference from a subscriber-provided router. This did not manifest in the polling and graphing of RSSI or CCQ stats at all. This lasted for 3 days before the subscriber finally called in. This is yet another case for managed routers, but even they are not immune to this effect. And then this is after changing the router frequency. We get immediate, measurable improvement. If not for Preseem, we would have only been able to see the stats of the CPE, which were great. And we would have likely dismissed this subscriber's complaints as illegitimate. We already knew this wasn't an issue with our network or equipment. However, with Preseem, we could now at least substantiate this subscriber's complaints of slowness and have a point of reference for improvement. And this subscriber was convinced that it was our network that was lousy and was causing this issue. Just look at the difference in latency before and after that router frequency change. Here we have a simple upgrade from a NanoStation M to a NanoStation AC. This had a great signal and CCQ before the upgrade, and there was no prior complaints from the subscriber. But yet, look at the difference in latency and throughput just from a simple swap from one radio to the other. The latency they were experiencing was crazy, and this was not visible from within any NMS we run. And then finally, at the subscriber level, I found a customer who's on our 25 megabit per second plan. Well, their router has some sort of auto QoS feature, which locks down its capacity and attempts to QoS on that capacity. Well, it was set to 4 meg. They've had the same router for over 5 years. They've upgraded 3 times in that time. Even 5 years ago, they were only getting 1/3 of their subscribed speed. Before we caught it, they were only getting 1/7 of their subscribed speed. This was impossible to see if not for Preseem. Sure, NMS could have shown us the throughput, but not this subscriber side latency, as NMS can only monitor the CPE or router themselves, not the feeling of the internet to the end user. So let's talk about what kind of an impact it had on our operations. Well, almost immediately, we identified hundreds of problematic APs, backhauls, and subscribers. We ceased virtually all installs because we did not have the resources or staffing to perform all of the required upgrades and fixes and fulfill all of the requests for service that we were getting. And moreover, we just kind of believed that it would be unethical to continue adding subscribers to our network when we knew good and well that they likely would not get their subscribed speed or have good QoE. We invested tens, maybe hundreds of thousands of dollars into equipment and labor required to perform the upgrades. And the daily review and analysis of Preseem trends kind of became the new standard for the upper level techs upon their arrival in the morning or immediately following any upgrades. Ironically, Preseem became the measuring stick for the effectiveness of all the upgrades and fixes, even ahead of the native NMS platforms from the manufacturers. So what kind of an impact did it have on performance and the subscriber experience, QoE, the meat? In 8 months, our subscriber throughput has increased from 2.5 gigabits per second to over 4 gigabits per second. And mind you, this is all while freezing installs for nearly 90 days. So what can I infer from this? Well, I can infer that we were operating at a massive bandwidth deficit, which we were blissfully unaware of. Fortunately, once we got Preseem integrated, Preseem's shaping engine kept the latency as low as possible for us while we were upgrading the network to provide more throughput. And then subscriber experience, our subscriber retention and satisfaction is at an all-time high. This is evident in both social media reviews and just the word of mouth increase that we've been getting. It really is all about the subscriber experience, guys. The subscriber's perception of reality is the reality. If they perceive the internet as being slow, then that is the experience they will share with their family and friends. They're either going to be your largest advocate or your largest trash talker. You see, you can't fix what you can't monitor, and you can't monitor what you can't see. If your tools can't record the data, then you absolutely cannot hope to fix the problems creating the data. Most subscribers are incapable of discerning the difference between problems with their equipment and problems with yours. Therefore, the problem is always with yours, right? You need to have the data to see what they're experiencing. If your tools can't record the data, then you can't hope to fix the problem. And I say there's a difference between monitoring the devices that deliver the internet and monitoring how your customers experience the internet. But at the end of the day, guess which one of those your subscribers actually care about?
Awesome. Thank you so much for that, Tyler. That's really useful. I'm really enjoying seeing your perspective of how you use Preseem. I'm usually on the other side of it. So seeing this kind of blow by blow is awesome to hear, of course. So again, thank you for that. Okay, so play to win. Your code here is free trial. You can see the spelling and all that here. Find the play to win tab on the left. Look for a sponsored challenge Preseem breakout session and enter the free trial code to get you 20 points. And then we're drawing winners every hour. At this point, we're going to go switch to live Q&A. So head to the group discussions tab and look for the session name. And Tyler and I will be here for 15, 20 minutes or so to answer any questions you may have. Thank you so much.
Thank you for tuning into this session at the WISP Virtual Summit, proudly presented by Preseem. Preseem is a one-of-a-kind networking solution developed exclusively for WISPs that helps to find and fix quality of experience issues across towers, access points, and subscribers. To learn more, visit Preseem.com today.